seeing we're looking at polynomials, just going to go over sketching polynomials. We've talked a bit about this already this year, so I don't think there's anything new in this. I think it's pretty much what we've seen before. So anyway, sketching polynomials. As with the linear function and the quadratic, in fact all polynomials, the y-intercept will be whatever the constant is. So if I was to sketch this polynomial, which has been factorised, of course I don't have to expand the whole thing out, because all I'm looking for is the constant number. So I just multiply the constants. 1 times -1 cubed times 2 squared, that'll be -4. All right, so let's plot that one in. Now the x-intercepts will be the roots or the solution to the equation, and because this has been nicely factorised for us already, that makes life easy. We're going to have one at -1, then the next one +1, and -2. So we know they're our x-intercepts. Out in infinity, a polynomial will always act like the leading term. So what's our leading term? X times x cubed times x squared, we're up to x to the power of 6. Now if we were to draw x to the power of 6, then you would draw the U shape. So we know this one will start up the top there, just like the x to the 6 would, and finish over there, again, just like the x to the 6 would. Now the actual roots themselves, the x-intercepts, will behave like the power of the factor. So if it's an even power, it'll touch it like a parabola or a U shape. Now we've got an even one there at -2. We also know it's starting up there, so we know the curve must come down and touch at -2. The odd powered ones, other than power of 1, will inflect like the cubic. So we've got a power of 3 there at +1. We know it's finishing over there, so it must come through with that sort of shape. Now, -1, it's going to cut like a straight line because it's just a linear factor. There's the actual shape. Now that we've done a bit of calculus, of course, we could work out that turning point a little bit more accurately. Because we know at that turning point there would be a horizontal tangent. Now I'm not suggesting we're going to go and differentiate that one, mind you, but we could and work out the actual x value of that turning point. If it can be completely factorised as x minus a to the power of something, then we've just got that basic curve, but it's been shifted left or right depending on what a is. Okay, same ideas, there's the answer, but let's just go over all those ideas. The constant, I would have gone, well, -1 to the power of 4, well that's 1, times 1 cubed, we're still at 1, times 2 squared, so we're at 4, times -2, so that y-intercept would be -8. We know the x-intercepts will be 1, -1, 2 and -2. We know it will start and finish like the leading term. So the leading one here, x to the 4 times x cubed, so we're up to x to the 7, times x squared, so that's x to the power of 9, times x would be x to the power of 10, but even power, so it would also have a U shape. So we know we're starting up at the top there, finishing over on the right hand side also at the top. Those roots will behave like the powers. So at +1, you see how it's a bit flatter at the base there, because it's power of 4, whereas over at -2 it's power of 2, so it looks more like your traditional parabola as it's coming down. And the cubic is at -1. So 10 there, so pretty much just a recap of stuff we've looked at already this year, but seeing we're looking at polynomials, good chance to look at that again.